Once you've started the software, click on the new project, give the appropriate name for the new project, set the proper units and press OK. The next step is usually to set the material properties. Open the new material dialog box and define the new material name. Afterwards, specify the material properties in the epsilon and mu fields, choose a color and press OK. The first construction step for modeling a planar structure is usually to define the substrate layer. This can easily be achieved by creating a brick made of substrate material in the box geometry section. The material settings of the brick must be changed to the desired substrate material. Provide the various values such as x1, y1, z1, values for x-axis, y-axis, z-axis. Select the material as the new material that we created previously and press OK. The next step is to model the slot line. Therefore, you should design copper plane of PEC material on top of the substrate. Provide the values of x1, y1, z1, then provide the values for x-axis, y-axis, z-axis, again do the same process for creating PEC plane 2. For this purpose, again go to the geometry select box and in the dialog box enter the transversal coordinates for x1, y1, z1, also we again need to provide the values for x-axis, y-axis and z-axis, and also select the material value. Once we have done this, the next step is to model the ground plane below the substrate. Therefore, you should again do the same process. For the dimensions of ground plane below substrate, you should design the ground plane of PEC patch. The material setting of the brick must be changed to the desired ground plane. Also, we need to provide the values for x1, y1, z1, and then provide the values for x-axis, y-axis, z-axis, and also change the value of the material. Once we have done this, the next step is to add the ports to the slot line device, for which the S parameters will later be calculated. Each port will simulate slot line structure that is connected to the structure at the port's plane. Plane wave ports are the most accurate way to calculate the S parameters of any microwave device and should thus be used here. To define the port 1, go to the excitation and then choose the voltage port. It will open a dialog box. Give the port name and approximate value and the appropriate dimension to define the exact port. Once you have done this, you need to create a second port. Give the name as port 2 and then define the coordinates as we did previously. We need to provide the values for x1, y1, z1, x2, Y2, Z2, port parameters, and press OK. Now we need to provide the value of Z max for the surrounding space. Once we have saved that value, now we need to provide the value for Zmin and Zmax in the boundary condition setup box. After doing this, we need to choose EM field visualization in the probes menu and select 2.67 as the frequency. The next step is the solver settings. For this, go to the solver by pressing the setup box. A dialog will open. Provide the various settings as per the formula. Now save the project. Once you have saved your project, you need to press the simulation button to start the calculation. A progress bar will appear in the status bar, displaying some information about the solver stages. Once the simulation is complete, we can go and check the results.